Hey everyone, welcome to Prep with Sid, where we break down technical interview questions step by step and focus on the thinking behind the solution. Today, we are covering one of the most common SQL interview patterns, top N per group. This pattern shows up whenever the business asks for the best or worst records inside each category. Take a look at these questions. Let's say Amazon wants to find the top 5 selling products in each product category. Or say Netflix wants to find the top 3 most watched movies in each country, or it could be in each region. Spotify wants to find the top 10 most streamed songs in each genre. Airbnb wants to know the top 5 hosts with the highest revenue in each city. All of these questions look different from a business perspective, but underneath, they're testing the same SQL pattern. You have a group, and that group can be a category, a country, region, city, genre, and inside each group, you need to rank records and return the top N. For today's example, we will use an Amazon-style question. Amazon wants to identify the top 3 selling products in each product category based on the total sales revenue. The important phrase is in each product category. That tells us we cannot just sort all the products globally. We need top products within each category. That means this is a top N per group problem. Let's create a simple product sales table. Each row represents a product sale with product, category, quantity, and unit price. Let's execute this. Okay, our table is ready. Let's insert some sample data. Here we have inserted 16 records, and in those 16 records, we have products across electronics, sports, and home. Some products have multiple sales rows, which is what we want for this example. Before ranking products, we first need product level revenue. Let's inspect the raw data first. This is a good habit in SQL interviews. We want to understand the grain of the table. Here, the grain is not one row per product. It is one row per sale, so we cannot rank immediately. Let's start working on a solution. Here you can see I'm ordering by revenue and looking at the top 3. So what this would do is this would calculate revenue for each row and then order by revenue descending the top 3. That gives us the top 3 sales rows overall. But the question is asking for the top 3 products in each category. So this is wrong for 2 reasons. First, it ranks individual rows instead of products. Second, it ranks globally instead of ranking within each category. Now let's look at the correct solution step by step. So step 1 is to aggregate to the correct grain. Since we need top selling products, we need one row per product inside each category. So we group by category, product ID, and product name. Then we calculate total revenue using quantity times unit price. Let's execute this. You can see now we have the data at the correct grain, which is mostly product ID and category. Now let's move on to step 2. What I'm going to do is I'm going to just wrap this SQL inside CTE so that we can work with that result set in the following steps. So what I'm doing is creating a CTE called product revenue, and we don't need order by here. We can do that later. And now I'll just select star from product revenue order by category total revenue descending. I didn't do much here. I just wrapped our initial SQL in step 1 in a CTE and just selecting from that CTE. Okay, perfect. You can see there's no change in result. Now comes the main logic. Here in step 3, we are going to rank the products within each category. Let's work on step 3. In step 3, we want to rank the products within each category. By now, you should know how you do the ranking. For ranking, there are a few different methods, but for this example, we are going to use a row number. And we are going to partition our result set by category, because that's what the question is asking. And then we are going to order within each category or within each partition by the total revenue in a descending order. Let's see how that's going to look. So I'm adding another CTE called ranked products. And here you can see I'm just doing the row number where and partitioning by category, order by total revenue descending. And to see what that does, let's just run a SQL on that ranked products. Let's investigate the data. Let's take a look. Now this is the key part. We use row number with partition by category. Partition by category means each category gets its own independent ranking. So electronics starts at rank 1, sports also starts at rank 1, and home also starts at rank 1. The order by total revenue descending means the highest revenue product within each category gets that rank of 1. Now let's work on the final solution. What we have done so far is we created first CTE to group the results by each product ID and product category. Then in the second step, we added the rank. Now within each category, we know how the products are ranked based on their revenue. Now in the third step is our final step where we want to figure out the top 3 selling products in each category. So let's take a look how that would work. Okay, so I'm just selecting some columns, or I could do select star from rank products where product rank is less than or equal to 3, order by category and product rank. This order by is just to see results in an order, but this is not necessary. Without this also, it will give you a top 3 products in each category. As you can see, this gives us the top 3 products inside each category. This is the core top n per group pattern. Now, if you are using Snowflake, you can make this cleaner using Qualify. Qualify lets us filter directly on a window function result. So instead of creating a separate ranked product CTE, we can calculate row number and filter it in the same query. I will leave it up to you to figure out how to use Qualify. It will be a good exercise for you if you have not used Qualify to figure out how it is used at the same place with the CTE. Now there could be follow-up questions. What if 2 products have the same revenue? Then row number will still force one product to be rank 1 and the other to be rank 2, which may not be what the business wants. Right? They may want to see top 3, and if there's a tie, they want to know both. So if the business wants tied products to share the same rank, then we would use the dense rank. The syntax for dense rank is very similar to the row number. Instead of row number here, we're just going to say dense rank. Now with the dense rank, products with the same revenue get the same rank. Now let's say if there are 2 products at rank 3. Business may want to know both the products. Then dense rank is what will give them that answer. Dense rank will show both the products with the same rank. So the main takeaway is this. Top n per group problem have a very repeatable pattern. First, aggregate to correct grain if needed. Second, use a window function with partition by group by. Third, order by the metrics you care about. And finally, filter to the top n. This pattern shows up in product analytics, sales analytics, marketplace analytics, streaming platforms, delivery platforms, and many other interview scenarios. Hopefully, this made the top N per group pattern feel more intuitive. The more SQL problems you break down this way, the more patterns you will start recognizing naturally. And once you start recognizing the patterns, the SQL becomes much easier. Thank you. Have a great day. I'll see you in the next one.